I hope all of you are doing good. Let's start today's chapter, Operations on Rational Numbers. Introduction. In class 6, we have learned in detail about fundamental operations of addition, subtraction, multiplication and division of integers. We have also learned about their properties. In this chapter, we shall learn about the operations of addition, subtraction, multiplication and division on rational numbers. We shall also learn about the properties of these operations on rational numbers. Okay. First, addition of rational numbers. Addition of rational numbers is similar to addition of fractions. However, before addition, we need to convert the rational numbers into rational numbers with positive denominators. For the purpose of addition, we divide rational numbers into two groups, namely rational numbers with same denominators and rational numbers with different denominators. Addition of rational numbers with same denominators. To add two rational numbers with the same denominators, we add their numerators while the denominators remain same. It follows that P by Q and R by Q are two rational numbers. Numbers with same denominator, then P by Q plus R by Q is what? Is P plus R by Q. Okay. The same should be reduced to the standard form whenever possible. Okay. Example 1. Let's check out example 1. 4 by 7 and minus 3 by 7. We have to add them. So 4 by 7 plus minus 3 by 7. So 4 minus 3 by 7 is 1 by 7. Okay. Addition of rational numbers with different denominators. To add rational numbers with different denominators, we follow the method we had followed for the addition of fractions. The procedure is as follows. Number 1, find the LCM of the denominators. 2, express each rational number with the LCM as a common denominator. 3, add the rational numbers and simplify. Okay, like we used to do in a fraction also. Okay, so here 2 by 5 and 3 minus 3 by 4 we have to add. Okay, 2 by 5 and 3 by 4. So first take the LCM. LCM of 5 and 4 is 20. So we'll multiply here by 4 and we'll also multiply here by 4. So 2 into 4 plus 4 into 5 into 5. So 3 into 5. Okay. So 8 plus 15 by 20 is what? 15 plus 8 is 23 by 20, or you can also convert it into mixed fraction. So we'll get 1 3 by 20. Okay. Properties of addition of rational numbers. The properties of addition of rational numbers are similar to that of properties of addition of integers. They are, number 1, closure property. The sum of two rational numbers is also a rational number. That is, if A and B are two rational numbers, then A plus B is also a rational number. Okay. For example, we have added 1 by 3 and 1 by 2, so we got this number, this rational number, which is 5 by 6, which is also a rational number, right? Next, commutative property. The sum of two rational numbers doesn't depend on the order in which they are added. Thus, if A and B are any two rational numbers, then A plus B is equals to B plus A. Okay. See, 1 plus 3 plus 1 by 4 is equals to 7 by 12. Similarly, 1 by 4 plus 1 by 3 means when we are just reversing the order, okay, or we are changing the orders, we'll get the same rational number, that is 7 by 12. Okay. Number 3, associative property. Sum of 3 or more rational numbers doesn't depend on the way the rational numbers are grouped. That is, A, B, C are any three rational numbers, then A plus B plus C is equals to A plus B plus C, or is equals to A plus C plus B, right? Example, consider rational numbers 1 by 3 minus 2 by 4 and 5 by 6. Okay. So first we will add in this order. Okay. So we'll get answer 5 by 12. Then we'll change the grouping. Again we'll get the same answer. Then again we'll change the grouping. Again we'll get the same answer. Okay. Number 4. So what does it show? That 3 or more rational numbers can be added in any group, any order, right? Number 4, identity property of a 0. Addition of 0 to any rational number leaves a rational number unchanged. That is, if A is a rational number, then A plus 0 is equals to 0 plus A is equals to A. 0 is called the identity element for the addition of rational number. Okay, whenever you add 0 to any rational number, you get the same rational number. Okay. Number 5, additive inverse, that is negative of a rational number. If the sum of two rational numbers is 0, then the two numbers are called additive inverse or negative of each other, such that if a and b are rational numbers such that a plus b is equals to 0, then a and b are additive inverse of each other. Okay. Example, 1 by 3 plus minus 1 by 3. What will you get? 1 minus 1 by 3, that is 0 by 3, that is 0. Okay. So here minus 1 by 3 is the additive inverse of 1 by 3. So additive inverse of minus 1 by 3 is 1 by 3. So the additive inverse of a rational number a is minus a. Also for any rational number a, we have minus a is equals to a. 0 is the only rational number which is its own negative inverse. Okay. Exercise 3.1. We have to add minus a 3 by 11 and a 5 by 11. Denominators are same. Minus 3 plus 5 is equals to 2 by 11, right? Subtraction of rational numbers. We know that subtraction is the inverse process of addition. Hence, subtracting a rational number means adding its additive inverse. Or while subtracting two rational numbers, add the additive inverse of the rational number that is being subtracted to the other rational number. Thus, if a and b are two rational numbers, then a minus b means a plus minus b. Let us consider some examples. We have to subtract minus 3 by 4 from 3 by 5 minus 3 by 4. So 3 by 5 plus 3 by 4. Now take the LCM, 20, 3 4s are 12 plus 3 5s are 15. 12 plus 15 is equals to 27 by 20. You can also convert it into mixed fraction also, right? Properties of subtraction of rational numbers. The properties of subtraction of rational numbers are similar to those of properties of subtraction of integers. The properties are the following. Number 1, closure property. The difference of two rational numbers is also a rational number. Thus, if a and b are two rational numbers, then a minus b is also a rational number. 2, commutativity. The subtraction of two rational numbers is not always commutative. That is, a minus b is not equals to b minus a. Consider the following examples. Okay, if you subtract 7 by 10 from 3 by 5, we'll get minus 1 by 10. But if you change the order, then in that case, you will get, if you subtract minus 3 by 5 from 7 by 10, you will get this answer, 1 by 10. Okay, that means a minus b is not equals to b minus a, right? Number 2 is associativity. The subtraction of rational numbers is not associative. That is for any numbers a, b and c. A minus b minus c is not equals to a minus b minus c. Okay. Here example, in this example, we can see that LHS is not equals to RHS, right? Number 4, property of 0. 0 subtracted from any rational number leaves it unchanged. That is, if a is a rational number, then a minus 0 is what? A. However, when we subtract any number from 0, we get its additive inverse. That is, if a is a rational number, then O minus a is a minus a, which is the additive inverse of a. Okay. Exercise 3.2, evaluate 3 by 8 minus 5 by 8. 3 by 8 minus 5 by 8. 3 minus 5 is equals to minus 2 by 8. Okay. Or 1 minus 1 by 4. Right. Multiplication of rational numbers. In earlier classes, we have learned how to multiply two fractions. Recall that product of two given fractions is a fraction whose numerator is a product of the numerators of the given fractions and whose denominator is a product of the denominators of the given fractions. In other words, product of two given fractions is equals to product of their numerators upon product of their denominators. The same is true for the multiplication of rational numbers. Means product of two rational numbers is equals to product of their numerators upon product of their denominators. Thus, if p by q and r by s two rational numbers, then p by q into r by s is equals to p into r upon q into s. Okay. Example, 5 by 3 we have to multiply by 5 by 8 by minus 3 by 4. Okay. We will multiply numerators and denominators. Okay. 5 3s are 15 minus 15 and 8 4s are 32, right? Properties of multiplication of rational numbers. These properties are similar to that of multiplication of integers. These properties are, number 1, closure property. The product of two rational numbers is also a rational number. That is, if a and b are two rational numbers, then a into b is also a rational number. Examples, 1 by 4 into 1 by 5 is equals to 1 by 20, and 1 by 20 is also a rational number, right? Number 2, commutative property. Two rational numbers can be multiplied in any order. That is, if A and B are two rational numbers, then A into B is equals to B into A. For example, 2 by 5 into 3 by 7 is what? Minus 6 by 35. Or if we change the order, minus 3 by 7 into 2 by 5 is equals to minus 6 by 35. Okay, so in both the cases, we'll get the same answer, right? Next is associative property. The product of 3 or more rational numbers doesn't depend on the grouping of them. That is, if A, B and C are 3 rational numbers, then A into B into C is equals to A into B into C. Okay. For example, if we change the groupings, we will again get the same answer, right? Number 4, identity property. The product of any rational number with 1 is the number itself. That is, if A is a rational number, then A into 1 is equals to A, and 1 into A is equals to A, right? One is called the multiplicative identity of rational numbers. Okay, for example, 2 by 5 into 1 means whenever you multiply any rational number by 1, you get the same rational number, right? 5, property of 0. The product of any rational number and 0 is 0. In other words, if 0 is multiplied to any rational number, the result is always 0. Thus, if A is any rational number, then A into 0 is equals to 0, or O into A is equals to 0, right? 6, distributive property of multiplication over addition and subtraction. Thus, if A, B and C are rational numbers, then A into B plus C is equals to A into B plus A into C, okay? And A into B minus C is what? Is equals to A into B minus A into C, okay? This is distributive property of multiplication over addition and distributive property over subtraction. Okay, note the reciprocal of 1 is 1 and the reciprocal of minus 1 is 1, and 1 and minus 1 are the only rational numbers which are their own reciprocals. Number 2, rational numbers 0 has no reciprocal or multiplicative inverse. Exercise 3.3, verify the property x into y is equals to y into x. Okay, value of x is minus 3 by 2, value of y is 5 by 6. Here 5 by 6 into minus 3 by 2. 3 1s are 3, 3 2s are 6. Minus 5 by 4 is equals to 3 1s are 3, 3 2s are 6. Minus 5 by 4. LHS is equals to RHS, hence verified, right? Division of rational numbers. We know that division is the inverse of multiplication. Thus, A into B is equals to C. Then C divided by B is equals to A, and C divided by A is equals to B. Okay. This fact is true for rational numbers also. In case of fractions, we have seen that division of fraction is the inverse of multiplication. For example, 1 by 2 divided by 3 by 5 is equals to 1 by 2 into 5 by 3, that is 5 by 6. This fact is true in the case of rational numbers too. Thus, we can say that if A and B are two rational numbers and B is not equals to 0, then A divided by B is equals to A into 1 by B, that is A by B. So, here A is the dividend, B is the divisor and AB is the quotient, right? Example 1, we have to divide 3 by minus 5 by 1 by 3. 3 by minus 5 into 3 by 1, okay. So, 3 3s are 9 by minus 5 or minus 9 by 5, okay. Properties of division of rational numbers. Number 1, when a rational number except 0 is divided by another rational number except 0, the quotient is always a rational number, closure property. For example, A by B divided by C by D is equals to AD by BC is also a rational number, right? Number 2, division of any rational number by itself gives the quotient. For example, 4 by 5 divided by 4 by 5, okay, 4 by 5 divided by 4 by 5 is equals to 1. How? 4 by 5 into 5 by 4 is equals to 1, okay. Number 3, when a rational number is divided by 1, the quotient is a rational number itself, okay. For 0 divided by any rational number is always equals to 0. Number 5, the division of rational number is neither commutative nor associative, right? Exercise 3.4. We have to simplify 7 by 9 divided by minus 3 by 4. 7 by 9 multiply 4 by minus 3. Okay. 7 into 4 is 28 and 3 into 9 is 27 minus, right? Absolute value of a rational number. In our previous classes, we have seen that the absolute value of an integer is the number regardless of its sign. The absolute value of a rational number is also defined in the same manner as follows. Absolute value, if x is any rational number, then the absolute value is denoted by this, okay, and is defined as absolute value of x is equals to x if x is greater than 0, 0 if x is equals to 0, and minus x if x is less than 0. Right? Example, absolute value of 3 by 5 is what? 3 by 5. Absolute value of minus 3 by 5 is what? 3 by 5. Okay. Next, properties of absolute values. Number 1, for every positive rational number a, there are exactly 2 rational numbers which have the absolute value a. They are a and minus a. For example, absolute value of 3 by 4 is 3 by 4 and absolute value of minus 3 by 4 is equals to 3 by 4. Number 2, 0 is the only rational number which has the absolute value 0. Number 3, there is no rational number whose absolute value is a negative rational number. For if a and b are any 2 rational numbers, then a plus absolute value of a plus b is less than or equals to absolute value of a plus absolute value of b, right? Number 5, if a and b are any 2 rational numbers, then absolute value of a into b is equals to absolute value of a into absolute value of b, right? Example 1, we have to verify that minus absolute value of minus a is equals to absolute value of a, where a is equals to minus 2 by 5. Okay, so absolute value of minus a is minus 2 by 5 and absolute value is 2 by 5, and absolute value of a, that is minus 2 by 5 is 2 by 5. Okay, this is LHS, this is RHS, and as you can see both are equal. Okay. Exercise 3.5, give the absolute value of the following. 2 by 3, absolute value of 2 by 3 is what? 2 by 3. Okay. Things to remember. If a, b and c are 3 rational numbers, then number 1, a plus b is a rational number. This is closure property of addition. 2, a plus b is equals to b plus a. This is commutative property of addition. 3, a plus b plus c is equals to a plus b plus c. This is associative property of addition. 4, a plus 0 is equals to 0 plus a is equals to a. 0 is the identity element for addition. 5, minus a, then in bracket minus a is equals to a. 6, if a plus b is equals to 0, then both a and b are additive inverse of each other. 7, a minus b is equals to a plus minus b. 8, a minus b is a rational number, closure property of subtraction. 9, a minus 0 is equals to a, but 0 minus a is equals to minus a. 10, a into b is a rational number, closure property of multiplication. 11, a into b is equals to b into c, that is commutative property of multiplication. 13, a into 1 is equals to 1 into a is equals to a. 1 is the identity element of multiplication. 14, a into 0 is equals to 0 and 0 into a is equals to 0. 15, this is the distributive property of multiplication over addition, and this is the distributive property of multiplication over subtraction. 16, b is the reciprocal or multiplicative inverse of a if a into b is equals to 1. The reciprocal of a is written as a raised to the power minus 1 or 1 by a, right? 17, the reciprocal of the non-zero rational number p by q is q by b. 18, a divided by b is equals to a into 1 by b. 19, a divided by b is a rational number. This is the closure property of division. 20, a divided by 1 is equals to a, and a divided by minus 1 is equals to minus a. 21, a divided by a is 1, a divided by minus a is equals to minus 1. 22, the absolute value of a rational number is its numerical value regardless of its sign. For a rational number a, its absolute value is written as this. Okay. 23, absolute value A is defined as, absolute value of A is A if A is greater than 0, absolute value of A is 0 if A is equals to 0, and absolute value of minus A, of absolute value of A is minus A if A is less than 0. Okay students, please, you should go through these properties and you will also do the practice of the remaining questions.